CyberChef is one awesome web-based application where you can do a ton of data manipulations, altering the format, doing whatever operations you might like for whatever purpose. Whether it's capture the flag, whether it's just general research, maybe cutting up some malware and malware analysis, it could be anything. And it is all client-side, it just runs JavaScript in your browser, but I'll be the first to admit, and I'll be honest, I have usually poo-pooed the use of CyberChef because it's not a saved sort of standalone solution that you could reuse or share with anyone else, unless it's some long, disgusting URL that you just sort of copy and paste around. I have just always preferred maybe putting together a script in some language like Python or Bash or whatever, so that you have a captured solution and it's not some temporary thing that just lives and dies in the browser. But I know the value of CyberChef and it just being a Swiss Army knife for whatever you want to do, and I thought I might show you this tool called Cheppy, or Sheppy, I don't know, however you want to call it here. It is a Python library with a handy CLI or command line interface that's aimed to mirror some of the capabilities of CyberChef. It is compatible with just about all the functionality of CyberChef in a pure Pythonic manner. So this is awesome, the best of both worlds. We'll dig into the documentation, we can look through some examples, but they showcase just how it might compare to CyberChef. And look, the code is super duper easy. Say you give it a file that you want to work with, and you can do whatever operations you might naturally already do within CyberChef. They roll through their advantages. You've got the command line interface, support in scripting, which is awesome, extendable via plugins, and all this sweet stuff. But they do note some of the disadvantages. Maybe not every single thing that CyberChef does, Sheppy can do as well. And don't get me wrong, you can do incredible things with CyberChef. One of my good friends and a past colleague, MB Research, is always sharing these awesome YouTube videos or even tutorials, tips and tricks on Twitter or X that all you can do with CyberChef, especially for the purpose of malware analysis. In this video that I pulled up here, he's digging into some of those advanced CyberChef techniques like flow control, cryptography, AES decryption, regular expressions, registers, all this awesome stuff. And I thought maybe it would be cool to showcase this just as well in the scripting language here, using Sheppy and putting it together in Python. But hey, big shout out to MB Research, credit where credit is due. Seriously, if you haven't seen his stuff, go check it out, it's awesome. So I am inside of my Kali Linux virtual machine. We're up to version 2024.1 now, so that's pretty exciting. But look, I could go ahead and install Sheppy. Pip install Sheppy. I think you could add in extras as it noted in the documentation if you wanted to get a little bit more features and functionality. I do already have it installed, but that would be ready to rock for you if you wanted to install it just as well. Now, MB did share the file, or at least the hash of the malware sample that he was looking at in that video. If we dig into the comments here, we can see it is provided. Look at that, this BEFC2 whatever. We can go track this down and pull it off VirusTotal. No secret sauce, nothing special there. We can just go ahead and paste in that hash and we can track it down. This file had only 9 detections, but I could just go ahead and download this. And I know not everyone has access to VirusTotal Enterprise, so look, I'll check in with MB Research if I can go ahead and slap this up on Malshare. I don't believe that is available yet, but let me check in and make sure I can share that with his permission. So back on the command line, I do have that downloaded in a malware directory. This was the netsupport_loader.vbs.txt. And sure, I should be working in Remnux or Flare, not in Kali, but hey, whatever. For the sake of scripting in Python, I'm just in my home base. Let me open this up in my text editor, Sublime Text, and I'll show you what we are up against. And again, this is the exact same sample that MB shared in his video. I just wanted to demo it with some scripting and using Sheppy, that command line Python rendition of CyberChef. Now note, there is a ton of data here, a bunch of decimal numbers that end up being manipulated some way, somehow. We actually could see at the very top of the file, it looks like it ends up subtracting out a QQT value, and that's set to 787, and that is going to end up being returned as characters. So this might be something that we could dig into if we pull all of this data out and subtract that value. Let's try to do that with Sheppy. Now we could go ahead and use this just from the command line. If I wanted to fire up any data that I wanted to supply, I could just use Sheppy and pass in that netSupportLoader.vbs.txt as an argument. And take a look. If I were to see the current state, look, that's just provided as our input. But if I hit tab, you can see all of the different things that Sheppy, or Cheppy, again, however we want to call it, could do. And look, it's just about all the same stuff that CyberChef offers. I keep pressing the down arrow to see all of these options here, and I really recommend, if you're interested and hey, you want to play with this, you do the very same. Just scroll through, see what sweet stuff you might be able to do, but all the same sort of states, all the same sort of flow, all the registers, stuff that you could do for some more logic and advanced use of CyberChef is still in the mix here. Even if I scroll all the way down, you'll get to see some green options for stuff that you could do just from the command line. The CLI gives you a whole lot of capability to do a little bit more work with the state or history, or even just where you are in the process of working with the data that you're working with, right? So say I could load a file, and that would give me everything that's included in the file here, but doing this from the command line, again, doesn't give me all that I want. I'd love to be able to pull this in to a Python script. So let me exit out here, and I'll create a new script to pull, I don't know, URLs referenced, because we will just ultimately try to extract and carve out some of the different layers or the stages of that malware sample to eventually find different URLs or pieces that it pulls more post-exploitation stuff from. So now that I've got that created here, I'll use my user bin environment Python 3 shebang line, and let me go ahead and import Sheppy. One thing that we could do is do a simple from Sheppy import capital Sheppy to get that object, and if we wanted to dig into the documentation, we could do that just as well. But we saw in the GitHub repository, look, this is pretty easy. We can just supply a Sheppy object here where we pass in our file that we wanted to work with. That was in home Kali malware. It was like net support loader or whatever. I got to go track that down. We could probably save that as another variable just as well. Let me say file name here. And yeah, that was net support underscore loader.vbs.text. So let's slap that in, and that should be our argument to the Sheppy object that we want to work with. Now we could keep doing things to this object. If we wanted to do a dot load file and then do a dot whatever we wanted following that, we could just as easily. They even showcase the syntax where maybe you wrap this in parentheses, and that way you could just as easily do a dot whatever on separate lines. That will be kind of neat. Hey, you could convert, do whatever, anything you might like in that sort of structure and style, but you could just as easily work with this C variable or the object that you create and do some more procedural stuff with that just as well. Honestly, I kind of prefer that route because that allows us to work with the registers or data that we might extract and pull out of it in the way that we might like, calling back the data as we need it. So let me do that. I'll just start with a simple C load file, and if I wanted to just print out C, validate that it's working here, I'll hit Control B on my keyboard, and that will spit out all of the output, everything that it has just read from the file. Now we can start to try and pull out this 787 value and subtract it from all of the stuff here in an automated way. And I'll be honest, I would recommend just as well, hey, scrolling through the documentation or trying to take a look at all the other functions that you might be able to use here. If we wanted to search for anything like a register, something that we might be able to use to save some data as we pull it out, we could set a register with some functions or use the get register or just even the function, the method register. That will extract data from the input and store it in a register like a variable for us to hold and work with. And of course, if you wanted to, you could just play an experiment with the command line interface, trying to see, hey, if we could load a file and then maybe we wanted to use some of the other functions, we could work with that and learn how those all work in an interactive way. But the cool thing about creating a register is that we could use like a regular expression pattern to be able to track down, find, and extract info that we might like to use later on, like that 787 number that we want to subtract from all the other variables or values in that big long array list. So let me look for any regular expression with a word character multiple times using the plus operator there with an equal sign in the mix. And then, hey, just trying to see, is it actually going to have a decimal value set or digits or just numbers, right? Could I find that and see what we pull out? I could actually examine those if I wanted to check out my registers with an underscore there for our C Sheppy object. Let me see what this does. Okay, cool. So we have one register defined at $R0. Very, very similar to CyberChef syntax just as well, where we're getting this QQT variable set to 787. Now I just want to pull out that value on its own. So I'm going to wrap this in parentheses, use that as a capture group. It also found some other interesting one, JUF, but can I pull that? I can. So now I have, whenever I need it, this get register function that I could call with the name $R0, and that should give me the sub value. Let me use that print that out to make sure that it is what it should be, and it is. Now, again, you could just do this with Python as you would like, but I think it is kind of nice to have this whole Swiss Army knife readily available to you, because when we get into some more complex stuff, like, just AES decryption or whatever, it's nice to have a rapid syntax to be able to do that without pulling in all those other libraries. And we've got, look, literally the Swiss Army knife to do what we want. Because again, malware analysis is an awesome use case for this, but you may just as well be using this for capture the flag, firing off exploits, beating up vulnerabilities, and actually, as we mentioned vulnerabilities, look, I'm trying my best with a whole lot of videos like these, trying to consistently get free education out for you all, but the only way that we can do that is with the help of sponsors and sponsorship. So please allow me to tell you about Snyk. Hey, don't trust this. Artificial intelligence can't always be trusted to write secure code. You've got to audit and review to make sure there aren't any vulnerabilities, and you shouldn't use the same tool to both write and secure any AI-generated code. Snyk's Deep Code AI takes a hybrid approach. It combines symbolic and generative AI alongside machine learning methods and the expertise of Snyk security researchers to provide the best code fixes without any hallucinations. Deep Code AI makes it easy to find and fix security issues in AI-generated code by scanning in real time. And I know, ChatGPT and GitHub Copilot can speed up development time, but they should be paired with security tools to make sure that your AI-generated code is secure. And that is where Snyk comes in. Snyk makes securing apps just as easy as it is to generate. Lightning-fast scans find vulnerabilities as you work and can generate a fix that you can implement with just a single click. Sign up for Snyk for free with my link below in the video description, jh.live/snyk-ai. Huge thanks to Snyk for sponsoring this video. Okay, so now that we've extracted that value, let's pull all of those decimal things that we saw in that netloader vbs.txt, all of this junk over here. We want to be able to subtract that out and turn it into what would be in the ASCII range, 255, because that's probably more bytes for a second stage or layer of the malware, right? So we could use a regex search and look for maybe the regular expressions prefixed with R with an array starting here with the literal parentheses, so I'll backslash to escape that, and then any decimal value over and over and over again, because there could be multiple of them, any digit here, with a comma that follows. And we'll wrap that in sort of a, square braces to match that in its own group, in a sense, and I want to get multiple of those. Will that work for me? Let me just see if I can print out the C value, and let's see what we have here. Okay, yeah, looks like we're getting all of that out, and a couple iterations of it to a certain extent. Do they do that multiple times in this? Do they have other arrays? Yeah, they do. Okay, I guess I'm just curious about the first one, so we could pull that out, and again, we could do this Pythonic way if we want, print out that index at whatever value. We could do that from the states, as we see, that should be returned out, and that's literally a list of ones that have been returned for us. Granted, it's just 0, the only state that's present right now, but maybe we just tune this to only return that single result with not using the plus sign there, but actually say, look, maybe we'll just get 100 or more of them. So comma denoting that will continue onward. Will that return out well for us? Let me just print C. That should give me just one result now. Yeah, it looks like it does. Okay. But I only want the decimal digits there. So let me wrap that in parentheses. There we go. That should set that as a capture group. So now I don't have the array and the opening, closing parentheses. And with that, we could now maybe split by a character. I believe I could just specify the comma here to denote, look, this will now just have a ton of these in their own byte representations, given a list. Oh, but that does include our opening square braces, kind of treating the actual list representation in Python as part of the value. So what we could do is before we split it up, let's actually convert that list to a string, list to str. How about that? There we go. Now I don't have the prefix square brace at the very top. And we don't need to print the sub value anymore, but that is one that we can know about. Now what I could do is just actually loop through a whole list. And that would be something that's really kind of cool because look, as I have all of these items kind of in the queue with Sheppy and CyberChef, the Pythonic way, I could actually call some other functions or use a callback for other methods, like converting them all to an int. That's passed as a string, but if you're curious, we could check out the documentation. Let me do a quick search for that loop list method that I'm referring to and take a look. It is something that you can use, looping over array and running a method on it. Now, all of these values are just integers, and since you are inside of Python, again, you can sort of deviate whenever you want between the tooling that Sheppy offers you and just sort of natural Python syntax. If we wanted some syntactic sugar, maybe we could say, hey, let's get the state, just the 0 state that's present there. That should just be what C naturally is, as we saw down below. Yep, that's all the integers there. But if that is an array, we could just as easily do some list comprehension if we wanted to. Maybe say I for I in that value. That's just the list. But if I wanted to treat that as an integer and then subtract out our Sheppy get register, noting that we stored that value above in R0. That will be a string by default, right? Because we didn't cast that earlier. It does give us an error about the int and string. So let me go ahead and cast that with wrapping parentheses of int. If I run this now, look at all these values that should be in normal natural ASCII decimal range that we could just convert into a character. But we'll bring that into Sheppy one more time if I were to change this print statement to a set state, where I could at any point just change whatever the input that CyberChef or Sheppy is working with, right? Now, again, seriously, I can just print whenever I want. See, that's all here. Now we could convert that all to the decimal values or the character representation of the next stage of malware. Since that currently is a list, we could go ahead and use c.loop_list one more time, and then say maybe from decimal, right? Because that will be treated as the character, and if I print all this out, you can see they're all bytes now, but hey, the B prefix of all these letters, what if I were to join these together? I can just do a simple c.join, and now we have what looks like another stage or sliver, another layer of this malware. Let me copy all this out. If I bring this to another file and zoom out a bit, it looks like this is PowerShell. So I could probably try to set the syntax to PowerShell within Sublime Text. Let me turn word wrap on just as well. And if I wanted to clean this up just in a quick way, hey, let's replace all those semicolons with new lines, spread that out a little bit. And this is doing something kind of interesting, right? We have this data, whatever, base 64 encoded, and then some other base 64 string, but then it uses some other variables with AES, or that encryption, what is that, advanced encryption standard? I might be getting the acronym wrong there, but it goes ahead, it uses this ECB mode with a key that's pulled from the variable that we saw above, just base 64 here, and then decrypts it. And then looks like continues and carries on its execution. But again, another stage of malware that we could cut up. But CyberChef, Sheppy, all this tooling makes it super duper easy to cruise through pulling out and then decrypting this AES values. So first things first, let's try to extract the AES key, which we know is this value, as that variable is referenced down below with the key that's defined here. So let's try and pull that out. It is base 64 encoded, and there look to be about, 44 characters. You can see it just barely down below, 44 characters selected. So let's define a regular expression that we might use for base 64 syntax. Let's just say base 64 regex could be any sort of value that's A to Z, A through capital Z, 0 through 9, and they also include plus signs, equal signs, and forward slashes, correct? So let's try to have that staged, and I don't know if that needs to be a regular expression right yet. We'll find out. Let's try to now use our c.regex search, or maybe we can store that in a register, right? Because we want to use that key for later once we do this operation. And we can always pull that into another variable in Python. So let's use a register. Let's say I want to look for that, hey, let's say use our format string in the mix, our base 64 regex, and then normally where I would use the quantifiers for how many of these that I want, knowing that's 44, because I'm using an F string or format string in Python, I will need to add 2 curly braces here. So kind of weird, doesn't look like real regex, but look, if I run that now, can I check out my registers, the underscore prefix, and it's looking good. We have a whole lot of these. R0 is pulling all of this stuff specific to the AES data itself over and over and over again. But I am just wanting this last entry. That's the key now in R27. Can I make that a little bit more specific? What could we hook onto there? Untitled was the current tab for that value. We could have the single quote surrounding it. Maybe that we'll use to wrap that down. Let me use a single quote, another single quote, and then a semicolon, but let me use parentheses to supply the capture group of just the base64 regex that I want. Will that return that out for me? Yes, perfect. Okay, so R0 is what it should be. R1 hasn't been clobbered yet for the register when we were looking for numbers previously, but that at least tells us that now our C get register, and that doesn't have a leading prefix underscore, but that should just be our AES key. And I can capture that as a variable in case I want to for that Python use case. But if I were to print that out, I'll use my F string to display nice and easy with the name. Oh, key not found in register? Oh, that should be the actual $R0 syntax. Sorry, I was getting state and register mixed up. Print that out. Look at that. We have the value that we should for our base64 encoded AES encryption key. Next, we need to pull out the actual AES data itself. And that's this DZXB variable with all the base64 data here. So look, we know that that's what's going to end up using trying to decrypt that. So you can see it ends up being decoded from base64 and then used later on. We could go ahead and just pull that out as well. Since the register lets us kind of keep something to the side of our not usual CyberChef kind of recipe that we're building up here, if we wanted to, we could just keep cruising and adding it more and more to the pipeline with our regex search as we had done previously. But let's search for our regular expressions that includes our base64 regex standard that we supplied, and that should be as many of these as it can get, right? What will that return? Can I print out the current value, the state stored in Sheppy right now? Oh, there's a lot to it. Okay, I guess that doesn't exactly help. Granted, it does pull it out, but it's not in an easy, simple way. It's not an index that I can readily get to, and that might be variable for maybe other samples similar to this. So could I just say, look, when we're looking for a $sign variable kind of being set to that, any specific word elements that we'd like, set equal to, and that was wrapped in what, single quotes? Yeah. Let me see if I could pull that. Wrap in single quotes multiple times, ending semicolon. Will that, if I capture strictly the base64 regex repeatedly, will that return for me? Let's print this C value out. Yes, it does. So now our 0 here, as we could see, is that return value. It is still in a list, and it is even getting the other one. So maybe we can truncate that, maybe say more than, hey, 50 or more, if we might like. And we should wrap that in 2 curly braces, right? Because we're using our F string. Now, when I run this, we pull only that value out, and I want to be able to work with that and that alone. Since it's a list, let me join that together to just pull the original value. Now, this is super easy. We can, from base64 to base64 decode that. It won't actually show it to us because now it's all raw bytes. But if we wanted to, you could use O to output or .out to be able to see that. So let me go ahead and do c.out, and I think that'll print it to the screen. No, we need to go ahead and, yeah, it is just a value or variable that we'll call. So c.out is what we will print, and that should give us all of the real raw bytes here. Now, if you notice at the very, very top, these are all the null bytes, and that is the initialization vector, in this case, for the AES encryption scheme. We'll need to carve that out, and it's worthwhile, hey, actually supplying that for AES decryptor. But if we actually go take a look at our documentation here, say I were to search for AES decrypt, it actually has this function that we could use, super duper easy, passing in the key that we might use, the initialization vector we might use, and then whatever data that's in the pipeline to be decrypted. We can pass in the mode, we can pass in the key format, base64 for our key, as we might have seen previously. And since it has a default value for the initialization vector, we don't really even need to care about it. So I don't think we need to parse it out. We can just drop those bytes. Let's do that. Let me do a c.drop bytes. And then I think you start from 0, the very beginning, and then 16 up to it. And that should remove all of those leading null bytes and bring us right to the data that is the actual encrypted stuff here. Now at this point, we could basically do the AES decryption. Let me just try c.aes decrypt. We know the key can be the value that we've already extracted out. The initialization vector we don't have to pass in because it uses the default for what we're already working with. The mode in this case should be ECB, as we saw that in the malware and the script here. It specifies that, but we do need to know that our key format is currently in base 64, not hex by default, as we saw in the documentation. Now, I gotta say, I ran into a whole lot of trouble with this because I kept getting a value error that the padding is incorrect, and it didn't seem to matter, look, what I was using for the key or the initialization vector or the data. All of it looked to be right, but I kept getting this issue, and I couldn't figure it out. Then I realized, hey, it's trying to call and reference some of the functions that are, native and inherent to the encryption encoding mechanisms of Sheppy. But it didn't seem to have that error when Matt or MB Research was showcasing this over on YouTube and everything that he kind of demoed. So I was just scratching my head trying to figure out what is wrong here. And I got to take a look back at CyberChef. And if I were to actually go look for that AES decrypt, I noticed, hey, if you supplied values, key, IV, change the format, everything that you already had sort of an interface to with the Sheppy library, but it also had some other opportunities to use a different mode with ECB and no padding. I didn't see MB Research use that, but it would seemingly work if we weren't getting an error about our padding being incorrect, right? Because again, if I run this, the error every single time is the padding is incorrect, and I could see what it's trying to call in the error and traceback of this AES decrypt function for the encryption encoding.py, the source code behind the library, where it would try to unpad and decrypt everything that was working with here. But I don't want it to worry about padding in this case, because that was what was giving me the error. So what I might try to do, honestly, is just look for this file and patch it out. Let me say, this is totally just an instance of a little hotfix, temporary band-aid solution. I think what we might like to do is probably put in a PR, or I don't know, maybe I'm just not smart, maybe I'm misunderstanding. I think this could be functionality for ECB, no padding, or other modes added to the library for Sheppy. But we've got everything that we need to be able to fix this problem. If I were to literally locate that encryption encoding.py file, I'm using the mlocate library. You might need to update your DB if you wanted to search across your file system like that. But if I open that file up, we could go to the exact line number that, hey, this error was coming from. If I actually hit Control G within Sublime Text, that was 933. And you can see, look, this is all the code and syntax that they use when you're working through this ECB mode decryption. And it's funny, you might have noticed in the documentation, I think this was a bad copy paste. Well, fix it in the PR, right? Decrypt raw state encrypted with DES or DES when we are talking about AES in this case. So maybe a little bit of Easter egg, and we can fix that up if we need to. But look, let's get back to this piece here, the snippet of code where padding.unpad is honestly not what we need. I just want to decrypt it. So let me comment that line out and then remove that function call. I swear, I know it's weird, I know it's dumb, but that will give us what we need. Now, if I save this file, go back to what we were working with, try to decrypt this, no error, and we have the data. If we weren't positive what we were looking at, hey, we could convert it to hex, we could represent it in any other way, but this is, if we actually look back at our code, the original malware sample here, it ends up using this as gzip data. They decompress what would be a gzip stream in this case. So we should do that just as well. And thankfully, CyberChef Sheppy makes this super duper easy. We could gzip decompress our current data And let's see if that works for me. Yeah, now we're getting some semi-readable next stage and a whole nother layer of what we're up against on this sample. So this is more PowerShell, right? That was invoked, that was just kind of, hey, inline ran. Let me see if we could do the very same sort of setup here. Let's go put this in another tab, remove what we were working with previously, set that syntax to PowerShell, and let's see if I could do a quick and easy replace semicolons to get at least a cursory idea of what this thing does. Because it looks like it has some functions and functionality that will, I don't know, stage some data, have a couple convenience functions, but they all use this another sort of obfuscation technique where they have these big numbers hiding the data that's meant to be behind it. And this WVA function looks to be over and over again used to decrypt that data or deobfuscate it, right? WVA, WBVA, WVA on all of these other locations. So that function that we see defined right up here in this block here, that takes this SHY variable and then once again subtracts it as the character representation of all of those numbers, digits here. So that is 4274. We can do the exact same process, extract that out, and then subtract as we need to. So you know the drill. Let's go ahead and create another register here where we could use a regular expression to search for. In this case, I'll look for the $anchor, right? Declaring a variable, and maybe that could be the start of a string or whatever, where we have a word character, that SHY variable, being set to another decimal value over and over again. And hey, that will have a semicolon to denote the end of it. Can I pull this out? Let's see what our C.registers are in a quick and easy way. And I'll comment out the whole output, so we don't need that right now. Looks like it doesn't seem to track it down. What did I get wrong there? Let me look back at that sample. Oh, there are no spaces in between. Okay, so that is just readily supplying the value. Let's remove those spaces, see if this gets it. There we go. R0 is now the value that we want, 4274. That is working well for us. And now we could go pull out all of the actual values that we wanted to try to deobfuscate or subtract that value from, just to see what that is, just to be able to do some quick deobfuscation in that automated way. So let me try to find any of those WVA, and again, I don't know, maybe that function would vary in other samples, but if we just blindly look for any array allocated and defined with the @ symbol parentheses, that could work for us. But hey, you know what? It's a worth for the showcase. Let me try to use that regex search and look for R for regular expressions, given a opening parentheses, and I'll add an @ sign there as the prefix of any data inside those parentheses where we have our decimal value, the number over and over and over again, and it could include a comma, but look, we want as many of those as we can get. So let me wrap that in some square braces and then use a plus sign to get as many as we can. Will this work for me? If I print out C in this case, C.out, C, it doesn't matter in this case, it will pull out those values. And you'll notice, look, this is an array. This is a list, and just ending our single quote for one item, there are multiple of these because we saw a couple different occurrences of those. We see one here, above, there's a second, there's a third, there's a fourth. So I'm curious what those all could be. And because we have multiple occurrences, different items in the list, what if we just simply loop through it? You could use a fork. You could use some of the logic and flow that Sheppy or CyberChef offers you. But again, whenever you want to, you can just bail out, bounce to Python. Whoa, geez, I said PowerShell because I was staring at that for a little bit. You can use whatever syntactic sugar or libraries or modules or whatever you want all inside of the script. And since these are all stored just in our state variable, and again, that is a list of these elements, we could do a little loop if we wanted to. We could do a for I or whatever item, it doesn't matter, in our C.state. We'll note that each of those individually is one occurrence of those decimal values. And look, if we wanted to subtract through them, we could. We could do a I.split, given the comma there. And then for each of the elements in there, we can just say X, we'll subtract out the value of the register that we saved just above, which again, could be a variable, could be anything that we want. That's the beauty of this. Let's do an subtract, and look, that should be an integer representation of the subtracting integer value of our register. C.getRegister, That should be our $R0, and that should give us now, once again, characters within the ASCII range. And look, since we're already here, we could just make this super duper easy. Let's just wrap this as a character representation, just plap that around in some more parentheses, and then we could join all of this together as its own individual string, and then we merge it all, and now we have some of those URLs, some of those other, hey, external locations or more obfuscated pieces that tells us, hey, potentially indicators of compromise or where it's grabbing its next stage, other malware, other things it could branch off from. And look, I mean, at this point, we've been able to carve out some of those URLs or other interesting tidbits in the malware sample. And if I like remove my comments, scrappy code that I've just been cutting up here, look, this is what, maybe 30 lines plus or minus, hey, stuff that I was just kind of staging for convenience and for use. And if you wanted to, you could dig into anything else. Like we can pull out the whole sample, unravel these layers, and then find other things. Like, look, different locations on the file system that might be referenced, different names of artifacts that could be left behind, the .zip, the infosec pad.exe. Those would be really cool to rapidly rip out with CyberChef or Cheppy, and I think doing it with Python, having it scripted and from the command line, gives us at least a little bit more reusable, kind of captured, saved, and stored solution that can stand on its own and be shared with anyone anyway. Maybe it's just personal preference, and maybe I am muddying the waters when you start to mix, Cheppy, CyberChef use case, and whatever Python syntax you want, but I think it does give you a whole lot of power, and I honestly just think that's a little bit nicer than the web browser, web app interface that lives and dies from a URL. I hope you thought that was cool. I hope you're willing to give Cheppy a try. And please, hey, if you're interested, please do give Sneak a try. Link in the video description. Huge thanks to all their support and sponsoring the channel and helping create videos just like these. Thank you so much for watching. Hope you enjoyed this video. If you did, please do all those YouTube algorithm things. Like, comment, subscribe, and I'll see you in the next one.